friends, myself Vicky Grua. Today we discuss the dimension formula and its applications. When we start to write a dimension formula, as we discuss what is dimensions, that is power that is raised on the fundamental units to represent a derived units. So how you will write a dimension formula? We will see it by a given example. Suppose if I want to find out the dimension formula for velocity. How can I find out the dimension formula for velocity? So first of all, we have to write the formula for velocity, that is displacement over time. As you know, the fundamental symbol of displacement is L and the symbol of time is T. So if you are moving with that, you can get the Lt minus 1. So here you can see we raised the power of 1 on the expression of L and minus 1 on T. So this Lt minus 1 will represent the dimension formula for velocity. In the similar process, we can get the different dimensional formula of different physical quantity. Generally we got the dimensional formula for derived quantities. We can take another example like acceleration. What is acceleration? Acceleration is defined as the rate of change of velocity, means simply I can say change in velocity upon time. I can write over here change in velocity over time. When you are going with change in velocity, what is change in velocity? Definitely it's the unit of change in velocity will be the same as the velocity. As we already got it, its unit is meter per second. So here also I can write Lt minus 1 by T. So in other form I can get Lt minus 2. So this is the dimension formula for acceleration. In the similar process, whatever be the units or the physical quantity given to you, you can find out a dimension formula for the given physical quantity. Suppose we take another example like suppose I'm just taking linear momentum. If I will define the linear momentum, it is defined as the product of mass and velocity. So I have written here m into v. M for mass and V for velocity. Clearly, what about the formula, what is the unit of mass? I certainly say it's kilogram. So I will write kilogram. If the unit of velocity, I will ask for unit of velocity, it will be meter per second. So I am writing here meter per second. So it means the unit of linear momentum should be kilogram meter per second. But if it is asked to write its dimension formula, so how you will use the dimension formula? As we have discussed earlier, you can write for kg, you can use the symbol m, and definitely there is power 1 on kg, so there is a power of 1 on m. And for mass, this m represent here length, so for this part you have to write L per second. So you have to write, because it is in upon, so you have to write T to the power minus 1. So m to the power 1, L to the power 1 and T to the power minus 1 will gives you the dimension formula for linear momentum. Here it is worth noting that sometimes the another physical quantity can have the same dimension formula too. For an example, this linear momentum, there is another physical quantity which have the same dimension formula. So you have to collect all these physical quantity which have the same dimension formula. For example, this linear momentum has a dimension formula of mLt to the power minus 1, and which also is a dimension formula of impulse of force. So you can see different physical quantities can have the same dimension formula, may or may not their formulas are same. Maybe their formula are same, maybe their formula are not same, but they may have the same dimensional formula. In the similar pattern, we can get various different dimensions formula for other physical quantity like work, torque. They have the same dimension formula. Energy has the same dimension formula too. So if I will write for that also, I can get work, torque. One more thing is there. If I am writing dimensional formula, so what I will do, I will take a big bracket to find out dimension formula. So I can write it like that: torque or energy. When I'm saying energy, energy of any type, heat energy, electric energy, whatever it is, and they have the dimension formula of work is force into displacement, like mass into acceleration into displacement. So it will be mass m lt minus 2 and L. So it has a dimension formula of ml2 t minus 2. So if it is asked what is the dimension formula of heat energy, you have to say ml2 t minus 2. If it is asked to you what is the dimension formula of electric energy, it will remain the same. So in this way you can find out the process how we get a dimension formula. Thank you.